The next question is from October-November 2014, and it's paper 1, variant 3, question 4. Three geometric progressions. Now we have three geometric progressions. It's P, Q, and then R, and they are such that their sum to infinity are the first three terms. Their sum to infinity are the first three terms respectively of an arithmetic progression. So we have the progression P, which is 2, 1, 1 by 2, 1 by 4, and we have the progression Q, which is 3, 1, 1 by 3, and a 1 by 9. So the question says find the sum to infinity of progression R. We are given progression P, we are given progression Q, and we are supposed to find the sum to infinity of the progression R. So that means for the progression R, I should be having the sum to infinity. Now the trick here is the word which says that their sum to infinity are the first three terms of an arithmetic progression. That means if I get the sum to infinity of P, for P, if I get the sum to infinity of P, and then for Q also, if I get the sum to infinity of Q, then these are going to be the first two terms of the arithmetic progression according to the question. So the sum to infinity is given as a over 1 minus r, and here I know that my a value for the progression of p is a 2, and my r value here is going to be a 1 by 2. So if I substitute these values, then sum to infinity for p is going to be 2 divided by 1 minus 1 by 2, or I can say it's 2 divided by 1 minus 1 by 2 is a 1 by 2, or I can say that the sum to infinity for p is going to be a 4. So this is going to be our sum to infinity for p. In the same manner, I shall be having the sum to infinity for q, and for q they have given us the first term, which is a 3, and also I can see that the common ratio here is a 1 by 3. So sum to infinity, substituting the values for a, which is a 3, and the common ratio, which is a 1 minus 1 by 3, I can see that the sum to infinity for q, the sum to infinity for q here be equal to 3 divided by a 2 by 3, or I can say it's 3 into 3 by 2, or this then shall be equal to 9 by 2 here. So these two, they are going to be the first two terms of the arithmetic progression. So for the arithmetic progression here, I can say that sum to infinity for p is the first term, sum to infinity for q 9 by 2 is the second term, and then sum to infinity for r shall be the third term. So this is our t1, this is our t2, and then this is going to be our t3. For arithmetic progression, we know that we shall be having the common difference, which is equals to t2 minus t1, or we can also say that this is equals to t3 minus t2. So T2 minus T1, substituting the term values, I should be having 9 by 2 minus a 4, which shall be equal to T3, which is sum to infinity for R, minus T2, which is going to be a negative 9 by 2. So 9 by 2 minus 4 is going to be a 1 by 2, and this then shall be equal to let's bring the negative 9 by 2 on the left side, so that this becomes a plus 9 by 2, which is equals to sum to infinity for r, or here I can say that it's sum to infinity for r, which shall be equal to a 10 by 2, or this is equals to a 5. So sum to infinity for r, this is what the question was asking for, and now we know that sum to infinity for r is equal to a 5. So this was part 1. Now for part 2, given that the first term of r is 4, now for the progression of r, we know that the first term is a 4, and the sum of the first three terms of r is what we are supposed to find out. So the first term is a 4 for part 2. The first term for the progression r, the first term is a 4. We have the sum to infinity for r, and this is equals to a 5. And we know that sum to infinity has the formula which is a divided by 1 minus r. Sum to infinity, I know that this is a 5. A value is a 4. It's just that we do not have 1 minus r. So 1 minus r then will be equal to a 4 by 5, or we can say it's 1 minus 4 by 5, which is equals to r. Therefore, the r value here is going to be a 1 by 5. So this is going to be the r value. But the question here has asked us for the sum of the first three terms. The question here has asked us for sum of the first three terms. This is what we are supposed to find out. So we have the a value, we have the r value, so that is not going to be difficult. We know that the sum of the first three terms, Sn, is equals to a times 1 minus r to the power n divided by 1 minus r. So substituting the a value, which is a 4, 1 minus 1 by 5, n value is a 3 divided by 1 minus 1 by 5. So sum of the first three terms then is going to be 4 times 1 minus 1 by 125 divided by a 1 minus 1 by 5, which will give me a 4 by 5 here. So S3 then is going to be 4 times 124 divided by 125 multiplied by a 5 by 4, reciprocating 4 by 5, that becomes a 5 by 4. Or we can say that the sum of the first three terms, the 4 gets simplified. Simplifying 4 and 125, that gives me a 25, or I can say it's a 124 divided by 25, or the sum of the first three terms for the progression r is going to be a 4.96. So this is going to be the answer for this question. So the next question that we are going to solve is from year 15, summer 2015, and variant 3, paper 1, question number 9. The first term of an arithmetic progression, is a negative 2, 2, 2, and 2, and the common difference is 17. So find the value of the first positive term. So for the first positive term, we should know that the term values needs to be greater than 0. So let's start taking in the data. For part A, we have the arithmetic progression. And for this arithmetic progression, we have the first term, which is a negative double 2, double 2. And the common difference D is a 17. We have to get the value of the first positive term. So for the first positive term, we should know that it needs to be the first positive term which should be greater than 0. Greater than 0 means the value becomes a positive. So Tn is given by A plus n minus 1 times D, and this should be greater than 0. A is a negative 2, 2, 2, and 2. We do not know the value of n, but we do know the value of D, which is a 17. This needs to be greater than a 0. So n minus 1 times 17 can be greater than a 2222, or we can say it's n minus 1 greater than 2222 divided by 17. So n here will be 2222 divided by 17, which is going to be 130.7, and then a plus 1. So n needs to be greater than 131.7, or I can say that the first term for which it's going to be greater than it should be a positive or greater than 0. That should be the value which is going to be a 132. So n should be equal to 132, or we can say that when the term is for nth term, which is 132, it's the first term which is going to be a positive in this very sequence that is given to us, for which the a is a negative 2, 2, 2, and 2. And they are asking for the value of the first positive term. So what is going to be the value of the first positive term? That shall be a Tn, which is equals to a plus n minus 1 times d, or it's going to be the term 132, which shall be equal to a negative 2, 2, 2, 2 plus n minus 132 minus 1, that gives me 131 times a 17. So let's get this value. So this is going to be plus 131 times 17, and I'm getting this answer as a 5, meaning 132nd term here will be equal to a positive value, which shall be equal to a 5 here. So this shall be my answer for this question. So this is one thing that I wanted to introduce, that whenever they say after giving some negative values that it should be the first value which should be a positive, then we should know that for positive terms, our terms need to be greater than 0. First value to be a negative, our term should be less than a 0 then. Let's do part B. Our first term of a geometric progression is under root 3. The second term is 2 cos theta, and the theta values are between 0 and pi. Find the set of values of theta for which the progression is convergent. So let's do the solution here. The first term, it's a GP, and for GP we have to have a common ratio. The first term given to us is under root 3. The second term given to us is 2 cos theta, where the theta values are between 0 and pi. So we need to find the set of values of theta for which the progression is convergent here. So if the progression is convergent, then I should know that my common ratio here needs to be between 1, negative 1, and 1. Common ratio we know is T2 by T1, and here it shall be 2 cos theta divided by under root 3. So 2 cos theta divided by under root 3, if I just substitute this common ratio here, then this is 2 cos theta over under root 3, which should be less than 1. I need to find the set of values of theta. Please remember, I need to find the set of values of theta which should be convergent, for which our common ratio has to be between negative 1 and a 1. And also, we are talking about the first and the second quadrant here. So we have this inequality, a continuous inequality from negative 1 less than 2 cos theta over under root 3, which is less than a 1 here. For the purpose of solution, I will be taking negative 1 to be less than 2 cos theta divided by under root 3, or the second equation shall be 2 cos theta over under root 3 divided by, less than a 1, meaning I shall be taking the first two terms and solving it separately, and then the last two inequalities to be solved separately here. Here this becomes negative under root 3 less than 2 cos theta, or I can say it's negative under root 3 over 2, which is less than cos theta. So if I bring this cos theta on my left, then I know that this inequality, the sign of inequality needs to change, and this is going to be negative under root 3 by 2. So negative under root 3 by 2, that shall be in the second quadrant, because in the second quadrant my cosine is a negative under root 3, that shall be in the negative quadrant, and this is the angle that I should be finding out here. This is the theta value I should be finding out here. But then to find this theta value, first I need to have the basic angle with respect to the x-axis, and for that I should simply say that my basic angle needs to be cos inverse under root 3 by 2. So cos inverse under root 3 by 2, that will give me by 6, and the general angle then, this theta angle then, is going to be a pi minus a pi by 6, and I can see here that my theta value here comes out to be a 5 pi by 6. So this is the value of theta that I should be having here. And if I solve with the second inequality that we have just made, I know that it's 2 cos of theta under root 3 divided by under root 3. So I can say this is 2 cos theta to be less than under root 3, or cos theta to be less than under root 3 by 2. So under root 3 by 2 again, and here I can so cos theta less than under root 3 by 2. I know that for this value here, because cos theta here is a positive, I have to have the angles between 0 and pi. So here my cos theta needs to be in the first quadrant, which shall give me the basic angle, or I can say that this should be my theta value here. So cos inverse under root 3 by 2. Cos inverse under root 3 by 2, that should give me the pi by 6 here. From here I can see, as the question was asking us for the set of values of theta, it has asked us for the set of values of theta for the progression to be convergent. Therefore here I should say that the set of values of theta has to be from pi by 6 to be less than theta, which is less than a 5 pi by 6 here. So this then is going to be the final answer to this question. Let's do another question. The question says that a water tank holds 2000 liters when full. So it's holding 2000 liters when full. A small hole in the base is gradually getting bigger so that each day a greater amount of water is lost. Part 1. On the first day after filling, 10 liters of water are lost. It's the first day. First day, 10 liters of water are lost, and this increases by 2 liters each day. So first day it's 10 liters, second day it's going to be a loss for 2 liters, and the third day it's going to be a loss again of 2 liters, and so on and on and on. Part A says how many liters will be lost on the 30th day after filling. On the 30th day after filling, um, how much liters, or how many liters will be lost on that day after filling here. So to get this answer, they have given us the volume of the tank, which is 2000 liters when full. So that gives us the total capacity of the tank. So here that's the hint that we should be using the sum formula here. It's the total capacity. The total capacity of the tank is going to be a 2000 liters. And then they are talking about the decrease in the leakage in the water tank. So there is going to be a decrease in the water capacity. On the first day, 10 liters of water is lost. So on the first day, it's 10 liters which is lost here. And then this increased by 2 liters each day. So our D needs to be a 2. How many liters will be lost on the 30th day? So this is what we are supposed to find out. So for part A, how many liters will be lost on the 30th day? That means it's T30, which I'm supposed to find out. So obviously T30, I'll be using the term formula which says it should be A plus 29D n minus 1, which is going to be 30 minus 1, that's going to give me a 29. Or I can say it's T30, which is equals to A, which is a 10 plus 29 times 2. We are talking about the loss here. First day it was a 10 liters loss, and then this will keep on increasing by 2 liters each day. So this then is going to be a 68 liters. So how many liters will be lost on the 30th day? So I know that it's going to be, the answer here is going to be a 68 liters. So this is going to be the answer for T 30th. Second part of the question says the tank becomes empty. The tank becomes empty during the nth day after filling. Find the value of n. So the tank is becoming empty. That means my S value needs to be a 0 here. So we need to find the value of n. The trick here is to understand that the tank is becoming empty during the nth day after filling. So after filling, that means that the total volume of the water when it was full was a 2000 liters. And this 2000 liters now is going to last for nth number of days. And this is the n value which we are supposed to find out. That means I should be using the sum formula n by 2 times 2a plus n minus 1 times d. I know the total capacity or the total amount of water that has been put in the tank, which is a 2000, and this equals n by 2 times 2 times a, which is a 10, plus n minus 1 times d, which is a 2 in this case. Solving it, I can say it's a 4000, which is equals to a n times 20 plus 2n minus 2, or I can say it's a 4000, which is equals to n times 20 minus 2, that's an 18 plus 2n. 4000, which is equals to 18n plus 2n squared. So it's a quadratic equation that I have. So solving it, I can say it's a 2n squared plus 18n minus 4000, which shall be equal to 0. Or I can say it's n squared plus 9n minus a 2000, which shall be equal to a 0. So solving this quadratic equation, n value here is a 40.44 and also a negative 49.45. So obviously the nth value here cannot be a negative. So I should be getting the answer as going to be a n value, which is a 40.44, or I can say that this nth value here is going to be a 41. So this is going to be the answer, or the term or the number of day, which is a 41, where the tank completely becomes empty. After 41, part 2. Assume instead that 10 liters of water are lost on the first day. So on the first day, 10 liters of water getting lost, and the amount of water lost increases by 10%. So 10% means we are following the geometric progression, where our geometric progression then here is going to be, let's start getting in the data. 10 liters of water are lost on the first day. Therefore, for part 2, I should say that my A value is a 10, and my common ratio, for the common ratio, I should say that it's T2, which is equals to 110, and my T1 in terms of percentage is going to be 100. Therefore, the common ratio here shall be 110 divided by 100, which should be equal to a 1.1. So whenever the common ratio or the amount is given in terms of percentage, we know that we are dealing with geometric progression, and increase means that it should be 100 plus 10, giving me 110, divided by 100 to convert it into a simple fraction. So 110 divided by 100 gives me a 1.1. So I have the common ratio. I have here the common ratio. I have here the first term, which is a 10. Find what percentage of the original 2000 liters is left in the tank at the end of the 30th day. So I need to find out the amount on the 30th day which is going to be left in the tank here. So for that, let's find out S of 30. S of 30 for the geometric progression then is going to be A times r to the power n minus 1 divided by r minus 1. Substituting the values, it's 10 and 1.1. N is a 30 here. Negative 1 divided by 1.1 minus 1. Or I can say it's S of 30, which is equals to 10 times 1.1 to the power 30 minus 1 is a 16.45 divided by 1.1 minus 1, that gives me a 0.1 here. So S of 30 then is going to be 1644.9 liters. So find what percentage of the original 2000 liters is left over here. So we can see this is the amount which is lost from the tank because of the leakage. And we are supposed to find out the percentage of the original 2000 liters left in the bank at the end of the 30th day. So the percentage to be left in the bank is going to be 2000 minus 1644.9 divided by 2000 and then multiplied by 100 to get the percentage value. So this percentage value then is going to be a 17.75%. So this is the amount this is the percentage amount of the original 2000 liters which is now left in the tank at the end of the 30th day here. So this is going to be the answer for this question. The next question is from summer 2018 and it's variant 2. And the question says, on a certain day, the height of a young bamboo plant was found to be 40 centimeters. After exactly one day, its height was found to be 41.2 meters. The height has increased from 40 to 41.2. Two different models are used to predict its height exactly 60 days after it was first measured. Model A assumes that the daily amount of growth in continuous Model A assumes that the daily amount of growth continues to be constant at the amount found for the first day. Daily amount of growth continues to be a constant, meaning here, if it continues to be constant, then we are saying that we are following an arithmetic progression by the common difference, which is going to be a constant value. Model B assumes that the daily percentage rate, we are talking about percentage rate of growth, it continues to be constant at the percentage rate. So obviously percentage rate, that means we are following a geometric progression here. So model A is representing arithmetic progression and model B is representing geometric progression. So using model A, find the predicted height in centimeters of the bamboo plant exactly 60 days after it was measured. So exactly 60 days after it was measured. So this is the statement that one needs to be aware of. They are saying we need to find the predicted height in centimeters of the bamboo plant exactly 60 days after it was first measured. So that gives me the total number of days here, which shall be equal to a 61. Exactly 60 days after the first day that it was measured, that means the first day needs to be inclusive, that is the first day plus another 60 days, giving me the n value as a 61. Now let's start taking in the data. They are saying the first day, on a certain day, it was found to be a 40 centimeters. So this is going to be the first day height, which is going to be 40 centimeters. And exactly one day, its height was found to be 41.2. So that means that my common difference needs to be a 41.2 minus 40, giving me the answer as a 1.2. So I have the D value, which is a 1.2 here. A is a 40, D is a 1.2, and I have N, which equals a 61. So we are supposed to find out the predicted height in centimeters, predicted height of the bamboo plant after 60 days after it was first measured, meaning N equals a 61. So that height then is going to be T of 61, which shall be equal to A, which is a 40, plus N minus 1, that's a 60, times the common difference, which is going to be a 1 by 1.2. Or on the 61st day, the height then is going to be a 40 centimeters. So on the 61st day, the height of this plant is going to be a 112 centimeters. Part B, using model B, and we have already discussed that model B has to represent a geometric progression. We need to have the predicted height in centimeters of the bamboo plant exactly 60 days after it was first measured, meaning here again the N value needs to be a 61. A obviously is going to be a 40, and R, as discussed earlier, the R here was going to be T2 by T1. First day it was a 40, second day it was a 41.2. So I can get the common ratio by saying it has to be a 41.2 divided by a 41.03. So I have the common ratio, which is a 1.03 as well. So this is going to be the data that I have, and I need to find the predicted height in centimeters on the 61st day. Therefore, I should say that the term here on the 61st day shall be equal to a r to the power n minus 1, or I can say that this height on the 61st day shall be equal to a 40 into 1.03 to the power 61 minus 1, which is a 60, and then this is going to be 135.66, or I can approximately say that this is going to be a 236 centimeters here. The predicted height according to this model on the 61st day is going to be a 236 centimeters. Next question is from winter 2022 paper 1 variant 1, and it's question number 7 here. A tool for putting fence post into the ground is called a post rammer. The distance in millimeters that the post sinks into the ground, the posts are getting sinked into the ground on each impact, meaning on each hit from the post rammer, the post just sinks into the ground, follows a geometric progression. The first three impacts cause the post to sink into the ground by 50. So on the first hit, the post sinks by 50 millimeters, then by 40, and then by 32. So we can see that the depth here is gradually decreasing by from 50 to 40 and then a 32. Verify that the ninth impact is the first impact in which the post sinks less than 10 millimeters into the ground. So it should be sinking less than 10 millimeters into the ground, and we have to verify that it should be the ninth impact, which is going to be the first one for this condition here. So from here, the three terms that I have, I know that my A value is a 50. My R value here is going to be a 40 divided by a 50, which shall be equal to a 4 by 5, or I can say it's a 0.8. Even at 32 by 40, that gives me a 0.8 here. So ninth impact, we are talking about the ninth impact, and we know for geometric progression, the terms are given as AR to the power n minus 4. We are talking about the ninth impact, which should be equal to AR to the power 8, and this should be less than 10 millimeters. We need to verify that this should be less than 10 millimeters here. So A value here is a 50 times R, which is a 0.8 to the power 8, and we should be verifying here that this value here should be less than a 10. So it's 50 times zero point 0.8 to power 8, and this value here is 8.39, which is obviously less than 10 millimeters. Let's check with T8. So with T8, I should say that this is going to be AR to the power 7. And if this value comes out to be greater than 10, then I know that the ninth term or the ninth hit is the first impact where the post first gets for less than 10 millimeters. So this then is going to be 50 into 0.8 to the power 7, and this answer comes out to be 10.5, which is greater than 10. Therefore, it's verified that it's the ninth term, which is the first impact, where the post is getting for less than 10 millimeters inside the ground here. After getting the values or the lengths by which the post gets into the ground, on the ninth impact, we can see that it is 8.39, which is obviously less than 10 millimeters. And just before the ninth impact, the eighth impact gives us the answer, which is 10.5, which is greater than 10. So this verifies that on the ninth impact, for the first time, the post gets by less than 10 millimeters inside the ground here. So this is verified.